Hello everyone, welcome back to week 2. This week we're going to do 6.1, which is property of exponents. I would say that this is probably the most complicated of the 5 weeks that you will be doing. I don't want you to get discouraged. I just want you to know that it is not going to continually get harder. I think this is the peak of hardness, and then it will start getting easier from here. This is going to be a 2-parter, so I'm going to have one video for like the first set, and then we're going to have a second video separately, but you will still only have one assignment, one homework assignment, and then one performance task for the week. But let's get started. So the first one is a 0 exponent. So off to the side, we're going to write anything to the 0 power is 1. So anything that has a 0 as an exponent will always be equal to 1. So if we look at examples A and B, we have 5 to the 0 power. And since it's to the 0 power, it's just equal to 1. And that's the same thing here. So whether it's a number as your base or a letter as your base, if there is a 0 in the exponent, it is just equal to 1. And then those are your final answers. So 0 exponent means it's a 1. Let's take a look at example 2. What is something to the power of 1? So we're going to go off to the side and we're going to write anything to the power of 1 is the base. So anything to the power of 1 is just the base. So if we were to take a look at examples A and B, the base is always the bigger number. So in this case, the base is 12, and here it is t. These are what is known as the base. It's whatever the exponent is on. So in this case, we have a 12 base with a 1 as an exponent. And because we have the 1 as the exponent, this 12 to the first power just equals 12. And here we have t to the first power. And since it's to the first power, it's just whatever the base is. So this just equals letter t. So that's it for when it's the power of 1. You basically can just pretend like it's not there and just take whatever number. All right, now we're going to look at negative exponents. And so we're going to go off to the side. We're going to write another note. And so this note is going to say when a negative power all right, so when you have a negative power, it appears to flip, or when you have a negative power, comma, flip it to the top or the bottom. All right, so when you have a negative power, you're going to flip it to either the top or the bottom, whichever the opposite is. All right, so if it starts on the top, you're going to flip it to the bottom, and if it's in the bottom, you're going to flip it to the top. So we're going to take a look at our examples A and B. So if you notice, we have a negative exponent. We have a negative 2. So it was in the top. So then we're going to flip to the bottom. All right, and so when I say flip to the bottom, you're going to say, okay, what does that actually mean? So we have this number here, and so this is going to be 1 over 3 to the second power. So it was like a whole number, and then we flipped it to the bottom of a fraction. And so for letter B, we're going to do the exact opposite. So in this case, c to the negative third starts in the bottom of a fraction. And so if it starts in the bottom, we're going to flip it to the top. So now it's going to be c to the third power. So was in bottom, flip to top. And so you're just kind of flipping it upside down or taking the reciprocal, if you remember what that word is, which is kind of where you flip it the other way. All right, now we're going to look at example 4. And so this is power of a product. Now, whenever we have a number outside of parentheses, what's your first instinct to do? What's the first thing you think of? I am hoping it is to distribute. So off to the side, we're going to write, when power is outside, so when the power is outside, sorry, it's like a little blurry. All right, when power is outside the parentheses, distribute to each piece on the inside. So when the power is on the outside of the parentheses, we're going to distribute it to each piece that is on the inside. So let's take a look at example A first. So we have AB on the inside with a 3 on the outside. So we're going to take it and we're going to distribute it to both pieces. So this is going to be equal to A to the third power, B to the third power. So you just took the third power as an exponent and put it on both of the numbers. And so that would be your final answer for letter A. Now, if you look at letter B, you still have stuff on the inside. Even though it's written as a fraction, we are still going to distribute the 2 to both pieces. So we're going to distribute the 2 to the 3 and the 2 to the y. So this is going to be equal to 3 to the second power over y to the second power. Now 3 to the second power, or 3 times 3, is just 9. So the final answer would be 9 over y squared. So this is the same as when we were doing multiplication before and you had a number out front. You distributed it to each piece. You're going to do the same this way. It just is now acting as an exponent and not multiplying it. However, power to a power, we are going to multiply. So we're going to slide to the side and we're going to write, when 2 powers appear next to each other, multiply them. So whenever there's 2 powers that appear next to each other, we are going to multiply them. Just like if you had a 2 and a 3 next to each other in an equation, you would multiply. We are going to multiply here. So let's take a look at examples A and B. All right, so in this case, we have the 4 and the 2 are right next to each other. So this is now going to be x 4 times 2. And 4 times 2 is 8. So this equals x to the 8th power. You just took those two numbers, and since they're right next to each other, we multiplied them. If we look at letter B, we are going to multiply both the m and the 3 because they are right next to each other. So this is going to be 5 to the m times 3 power, but those both aren't numbers, so it's just equal to 5 to the 3m power. Remember, the number always goes in front of the letter, not reversed. All right, we have 2 more rules for this video. On this, we're going to talk about multiplication and division of exponents. So multiplication in this case is always going to go with addition. Multiplication goes with addition. You can think always getting bigger, right? When you multiply, you get more. When you add things together, you get more. And so if multiplication goes with addition, then division is going to go with subtraction. Division is going to go with subtraction. Division, you're dividing things into smaller groups, or subtraction, you are taking things away. We're going to talk about product of powers first. And so product is multiplying. If you notice, there's a multiplication symbol. All right, and so since we have a multiplication symbol, multiplication means add. Multiply means add. So this is going to be equal to A. We're going to add the exponents 4 plus 3. We just took the 4 and the 3 and we added them together. So this would equal A to the 7th power. Whenever you're taking things and they are being multiplied, you just add your 2 exponents, 4 plus 3, and you get A to the 7th power. However, if we look at letter B, all right, I want to have these simultaneous, yeah. So if you look at letter A, they're both bases are letter A. However, in letter B, if you notice, this is a B and this is an A. Bases are not the same. And since both the bases are not the same, the A and the B are different, you can't do anything. So whenever you have bases that are not the same, whether they're letters or numbers, you can't do anything. You just let it go. Nothing to do. Move on. All right, let's take a look at our last example. So quotient means division. All right, so this right here, since we're dividing, division means subtract. So in this case, we're going to subtract the exponents. So we're going to have m 6 minus 4. So both of them are m's, so we're good to go. We're dividing, so we subtract. So 6 minus 4, this would be m squared, because 6 minus 4 is 2. And that would be your final answer. For letter B, if we go and look, do you notice how this one's a P and this one's a C? Those bases are not the same. And since the bases are not the same, you do nothing. And so then you just leave it as P to the 3rd power over C to the 7th power. Now I know we just went through 7 different rules, which might seem like kind of a lot. So at the bottom of the notes, I did include a little table for you to also look at for later reference. There is no homework assignment that goes directly with this video, but after the second video, there is a homework assignment with 12 problems. If you have any questions, please let me know.